Hey guys, Mr. Jenkins here, back with your last section of Chapter 4. So just to kind of recap, we've covered Chapter 4 in 2 units. So this unit is concluding with Section 4.9, which is about solving a linear and quadratic system, or it could be a double quadratic system, but basically systems involving quadratic equations. So we're going to look at that to wrap up this last unit, which will be over 4.6 through 4.9, and your test over those 4 sections will be on Tuesday, which I think is the 24th. I think that's right. All right, so just some of the basics, and then we'll jump in and I think I'm going to show you 3 examples, and then there are a couple more on the filled out notes that you can look at. So just the basics here. The equations will intersect in 2 locations. Those have two solutions. Remember, those are the solutions to any system, as those points of intersection. So this would have 2 real solutions. If they intersect in one spot, that would be 1 real solution. If there is that space there and you can tell that they're never going to intersect, then that would be have no real solution, or 2 complex solutions. Okay, so let's go ahead and solve this first one graphically. All right, so our system is y equals negative x squared plus 2x plus 4, which you can see that I have gone ahead and typed that into Desmos. And our linear equation is x plus y equals 4, right? So, and then basically we're just looking for where do they intersect, okay? This notes, that it has the table there. I'm not going to really bother filling out the table. I will make sure that I produce a good graph, though. So I want to know, like on my parabola, where is my vertex? So it looks like that's at, I'm pretty zoomed in here. Let me maybe zoom out 1. All right, zoom the wrong way. So now I'm kind of counting by 1s. This will be easier to tell where everything is. So it looks like my vertex is at 1, 5. So right there, and then it looks like I just go down 1, right 1, down 1, left 1. And then I can go down 1, 2, 3, 4, right 2, down 4, left 2. Okay, so that's a pretty good snapshot of my parabola. And then my line, I can always think about the intercepts here. Looks like my x-intercept would be at 4, 0. And my y-intercept would be at 0, 4. And I'll make it look nice and neat here. Grab the straight line tool. Just so it looks nice for the notes. But the big thing is we really didn't, if this were a test question, we would want to have a nice graph. But the big thing is that you understand that this and this are kind of what's important. So the point 0, 4 and the point that looks like 3, 1. And we can confirm just by clicking on our graph over here. So 0, 4, 3, 1. Right. Remember, if we ever had just a linear system, we would only have 1 system or infinitely many systems, right? But a lot of these that involve a quadratic, because we have that change of direction, will have 2 solutions. Okay, and then remember, you can always sub these back in just to make sure they work. So obviously 3, 1 adds to 4. And, this would take a little bit more time, but if I subbed in 3 there and 3 there, I should get 1 there. 0 plus 4 is obviously 4. And if I sub in zeros here, that's pretty easy to tell that I would get 4 there. Okay, so you can check those algebraically. Okay, the one that you'll have to do on the test, and there's a snapshot of my graph there, but the one that you'll have to do on the test, you'll have to show your work using substitution. Okay, so that's where I wanted to spend most of the time. All right, so solve using substitution. So we have y equals x squared plus 3x plus 9, and y equals negative 3x plus 4, right? So we know how to use the substitution method. If y is set equal to negative 3x plus 4, then we can sub negative 3x plus 4 in for y in the other equation. So that would give me negative 3x plus 4 equal to x squared plus 3x plus 9. So now I'm going to approach this like I'm going to solve a quadratic equation. Okay, so the first thing I would want to do to make that happen is write my quadratic equation in standard form. Okay, so I'm going to add 3x to both sides. That's going to give me x squared, and then 3x plus 3x is plus 6x. And I'm going to subtract 4 from both sides. So 9 minus 4 is plus 5. And then over on the other side, I have 0 left. Okay. My first thought, and I hope your first thought is always, if I'm trying to solve this, can I factor it? Right? A lot of people jump right to the quadratic formula, but this can easily be factored, right? What's going to add to give me, what's going to multiply to give me 5 times 1 is 5, and what's going to add to give me 6, right? So that would be 5 and 1. So that's going to be x plus 1 times x plus 5. Okay, that's how it's going to factor out. And so now I can easily solve by using the zero product property to get that x equals, remember this, x plus 1 equals 0, so x equals negative 1, and x equals negative 5. Okay, at that point, it's going to kind of feel like you're done, right? Because if we're just solving a quadratic, we are done. But remember on this, we are solving a system, right? So we have our x coordinates. So at this point, we know our answers are going to be negative 1 comma something and negative 5 comma something, right? So you gotta sub back in to get your y coordinate. Okay, so I always recommend sub into both, but just for brevity to kind of go a little bit quicker, I'm just going to sub into my linear equation. So we'd have y equals negative 3 times negative 1 plus 4. That'd be 3 plus 4 is 7. So negative 1 goes to 7, and negative 5 goes to what? Y equals negative 3 times negative 5 plus 4. So 15 plus 4 would be 19. All right, so just, to double check that algebraically, you would want to see that that happens in the quadratic as well. But since we have all these technology tools, this would be a slick way to kind of check your answer too. And hopefully you were kind of thinking this, but what if we just type these in and just see where they intersect? So let's do that, which I have saved. All right, so let's see. Do they cross at negative 1, 7 and negative 5, 19? Let me just zoom in a little bit there. So it looks like negative 1, 7, negative 5, 19. I've confirmed my answers. I'll go ahead and box those in. The big thing, though, is that you're able to do this initial kind of substitution step. Okay? So I bet you're probably wondering, Mr. Jenkins, you're getting soft here using red and black Louisville Cardinal colors. Gee whiz. I don't know what's wrong with me today, guys. It's these virtual Wednesdays. Anyways, on a serious note, let's go ahead and look at example 2. So on example 2, I'm going to go ahead and jump ahead and go ahead and check my answer first. Okay, let's go ahead and do that. Looking at those, see one's a open up parabola, one's an open down parabola. That they clearly have this void in between them, so they're not going to cross anywhere, right? So in this case, then I know I'm going to have those complex solutions, right? So let's go ahead and try to produce those answers, right? You won't have one like this on the test, but I wanted to show it anyways, so I'll try to go a little quick here. So solving by substitution, my first step would be I'm going to sub negative x squared minus 5 for that y. So negative x squared minus 5 equals x squared minus 4x plus 5. Now we're going to write in standard form. Adding x squared to both sides will give me 2x squared over here. Minus 4x is going to stay minus 4x, and then add 5 to both sides to make that last term plus 10. All right, so then you might, hopefully you know, like you already checked your answer, this is not going to be able to factor if we don't have any real solutions. So let's go ahead and jump to the quadratic formula. Or we could, so I don't think I've hit on this either. So you would not want to try to complete the square on this one, because your lead coefficient is not 1. All right. If you really like complete the square, you could factor out a 2 and do it that way. That'd be fine. But I'm going to go ahead and use quadratic formula. So x equals negative b. So that'd be positive 4 plus or minus the square root of negative 4 squared. I'm just going to write 4 squared minus 4 times a times c. All of that over 2 times a. So go ahead and simplify what's under the radical. So that's going to be 4 plus or minus the square root of, let's see, what do we have? 16 minus 80. Let's see, just look at my notes there. So that's going to be minus 64, or negative 64. There's where we see our answer is going to be complex, right? Because we have a negative under the radical, and all that's over 4. Okay, so if this were on a test, we would want to continue to kind of work this out. So good review anyways. So as I do, I would get 4 over 4 plus or minus. That'd be equal to 8i over 4. Which we can simplify down to 1 plus or minus 2i. All right, so that would be actually my x coordinates. Okay, and like I said, this next part won't be on a test, but it's good review of 4-8 anyway, so I'll go ahead and show the rest of it. All right, so now if we wanted to get the y coordinates, right? So at this point, we would know that my answers are going to be 1 plus 2i, comma, something. And 1 minus 2i, comma, something else. Okay, so let's go ahead and just sub into the easier quadratic and see if we can produce a y value. Okay, so let's go ahead and sub in 1 plus 2i right there. All right, so if I have 1 plus 2i squared, and you could just write that out as 1 plus 2i times 1 plus 2i, but it's also kind of a shortcut problem. So that would be 1 squared, so 1 plus 2ab, so 2 times 2 times 1 times b, so that'd be 4i. And then plus b squared, so plus 4i squared. So as you can see, this gets a little complicated. Then we distribute to get negative 1 minus 4i minus 4i squared plus 5. Then combine your like terms. So we'd have -1, that's +4, remember. So my real number is 3. Sorry. We have a +5 also. 3 plus 5 is 8. So 8, and then -4i. 8 minus 4i would be my y coordinate. Which is wrong, so I'll try that again. So go ahead and multiply this out. Okay, so 1 plus 2i squared. Let's go ahead and see what that looks like. There is a shortcut here, but I'm going to multiply it out real quick. That would give me 1 plus 2i plus 2i plus 4i squared. So altogether, that'd be 1 minus 3 is negative. 1 minus 4 is -3. So -3, and then plus 4i. And then we have the plus I. So distribute your negative. That would give you 3 plus. Let's see. What am I doing wrong? -3 plus 4i. Oh, it's -5. Okay. Oh, I see what I did. All right, so we're going to try one more time here to see if we can get the y coordinates. Now, this next part is complicated, so I wouldn't worry too much about it. Like I said, this part is not really on your test. I'm just going to sub into here and just see what we get. So that'd be y equals, let's sub in 1 plus 2i. All right, -1 plus 2i squared plus 5. All right, so 1 plus 2i squared. That would end up being, okay, that would end up being 1 plus 2i plus 2i plus 2i or plus 4i squared. And so that's 1 minus 3, or 1 minus 4 is -3 plus 4i. So that is -3 plus 4i. All right, that is plus 5. So that ends up being 3 minus 4i plus 5, which is -4i plus 8. Okay, so -4i plus 8. And then the last one is going to be, we're going to sub in 1 minus 2i, right? See what we get there. Like I said, just a reminder, you know, this won't be on the test, but just kind of showing you that how, you know, these complex solutions could be kind of a mess. So then we have 1 minus 2i squared. So -1 minus 2i squared. That's going to be 1i, or sorry. Let's go ahead and write that out as 1 minus 2i times 1 minus 2i. So that'd be 1 minus 2i minus 2i plus 4i squared. So then you have 1 minus 4 is negative 3 minus 4i. Okay, then you have your negative, distribute that, so that gives you 3 plus 4i. So that's going to give you 8 plus 4i. Okay, so you got 8 plus 4i and 8 minus 4i. Okay, like I said, example 2 is not going to be on the test. It's going to be more like example 1. So if I lost you, just focus on example 1. There are 2 more like it on the try it number 1 and the try it number 2. Okay, those are the big ones you got to be able to get. Thanks and have a good one.